Okay, now we're going to talk about finding inverses. Remember what I said about logs and exponentials? They are inverse of each other. In fact, if you look at the graph, exponential goes this way, logs go this way, and if there's, look at the 45-degree angle, if you can fold graphs on top of each other across this diagonal line, you know that they're inverses. Here are the steps. Let me cover that up. Here are the steps to solving inverses. Make sure that it's in y is equal to whatever form. Then swap out x and y. Put the x on the left side, then y where the x was. Then you want to get the y by itself again. Solve for y. And once you have y by itself and you're completely simplified everything, you go ahead and put the inverse notation. So let's get started. Okay. And I should have done this first. Okay. So y is equal to log 3 to the x. And you should always have that in parentheses. Well, first thing we're going to do is swap out the x's and the y's. So there we have it. All right. And then there's nothing else you can do. Remember inverses. The inverse of log notation is exponential notation. So our invisible base is 10. We would write 10 to the n. There's the a right there. So let's go ahead. Those do not want to go away very easily. So this 10 raised to the x, and then the log goes away. 3 to the y. And then remember, you can actually use that information to go ahead and rewrite everything in logarithmic form. Now we have, here's our base to the y value. The y is the exponent, and this whole thing is the a. So log base b3 to the a value, and I usually put the exponent on the outside, is equal to y, and since that's simplified, we're going to put y to the raised -1. All right, and we're going to shift over to, now we have a natural log, and just remember that every single natural log, the base is the letter E. So we're going to swap out the x's and the y's. Let me move this out of the way. So the y is now in here. Well, there's stuff. We need to get the the natural log base C of y. We need to get that by itself. So we're going to add the 8 to both sides. And once we do that, we can go ahead and write that log in exponential form. So here's our base. This whole thing is the a value, and b to the n is equal, oh, sorry, the teacher just wrote that differently. All right, so let's go ahead and rewrite that. Yeah, I had that correct. B to the n is equal to a. And then there you have it. E to the exponent x plus 8 is equal to y. And then since this is the inverse of that, we write it with the inverse notation. I think that, oh, we've got a couple more. All right, find the inverse of each function. You swap out the x's and the y's. Since the subtract 6 is on the inside, this is in log form. We can write it in exponential form. So 5 to the x is equal, remember, this is the b, this is the n, this is the a. Whoops. So 5 to the x is equal to y subtract 6. Well, now we just add 6 to both sides. So 5 to the x plus 6 is equal to y, and because that's simplified, we go ahead and put the inverse notation. Over here, y is equal to 10 to the x divided 3, that exponent, x over 3. We swap out the x's and the y's, and now we have it in exponential form. The only thing we can do now is rewrite it in log form. Here's our base. This is our n. This is our a. So, log base 10 of a is equal to the exponent. Y divide 3. Well, then we're just going to cancel both sides by the dividing 3 by multiplying both sides. But remember, if there's a number in front, to condense it down, you move it back as an exponent. So now we have, after we simplify it fully, then you can go ahead and write the inverse notation. All right, that's it for this one.